Hey guys, Travis Gillespie. In the last video we talked about finding the measures and categorizing triangles. So being able to find those measures of triangles is important. And just as important are polygons. To be able to classify and find the measures of polygons is just as important. So let's take a look here. What are polygons actually? Well, they are closed plane figures formed by three or more segments. It means that it's a closed plane and it is formed by three or more figures. Well, could a triangle actually be a polygon? Well, let's see here. Does it have three or more sides? Absolutely. And are triangles closed planes? Absolutely. So it works. Well, what about a quadrilateral? Yeah, absolutely, because as long as it's a figure that is closed, there we go, and it has three or more sides, yeah, it has to be a polygon. Polygon. Yep. What about heptagon? What? Let's look down at that guy. 7 sides. That sounds pretty cool. So what would that actually look like? We got 1, 2, 3, 4, 5, 6, and 7. So I've got 7 sides. Cool. And now the next thing that I'm being asked to do here is let's actually go ahead and find the measure of the angles of this heptagon. Well, how can we actually, or you or I actually go about doing this? Well, a triangle is a polygon, and these are all polygons, and you actually know that the triangle sum formula tells you, hey, that theorem tells you that in the formula that all of the angles on the inside of the triangle added up equal 180 degrees. So let's take what you know about triangles and actually apply it to this heptagon problem. So what I want to do here is I'm going to take this heptagon and I'm going to draw as many triangles I can from one vertex within this heptagon. First thing I want to do is change the size of my line tool, and I'll just use this vertex to form as many triangles as I can. So let's see here. Yeah, well, that's one triangle right there. Oops. I have a second triangle right here. The third. And let's see, I got one more line right there. So I got 1, 2, 3, 4, and actually 5 triangles. And, well, as said before, each triangle has 180 degrees plus 180 degrees plus 180 degrees. So 180 degrees times 5 for the heptagon here. So all that I actually have to do here is say, hey, 5 times 180 for the 5 triangles here. Well, that's simple. That equals 900 degrees. Cool stuff. Just going to change my degrees there. And I'll just take it out. It wasn't there before. So the 7 angles in a heptagon actually equal 900 degrees. Let's try one more. So let's take a look at what an octagon. I'm going to see if I can keep as much of the heptagon on screen. Throw an octagon right over here. See what we can do with this guy. Well, I'm going to treat it the same way that I did with the heptagon. I'm just going to create lines from one vertex. Let's start right here. Okay, so the first one that I can create, well, there's one triangle. Second triangle. The third. triangle. So now I have 1, 2, 3, 4, 5, and 6 triangles, and I'm going to go ahead and label those on the inside just to say that I know how many that I have. So now I know I have 6 triangles inside of one octagon. So each triangle has an internal measure of degrees of 180. So I know that 6 times 180 equals, and what you end up with here is 1080 degrees, or a 1080. Great. Well, have fun playing with polygons and finding the measures within inside.